This is lesson 7-5. We're learning to factor today. So the first example that you're supposed to write on your notebook paper is that we're factoring x squared plus 7x plus 12. So we need to figure out what the dimensions of this rectangle is. So first, we need to make a rectangle. Now I'm just going to do it up here instead of passing out or having Miss Lemons pass out all those algebra tiles and do all that. I'm just going to do it right here. So we just have that one x squared tile, then I have 7x tiles. So 1, 2, 3, 4, 5, 6, 7. Now we need to make this into a rectangle and also with these 12 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Somehow I need to make a rectangle out of this, so I can already tell I'm going to have to turn some of these x tiles the other direction. So I'm going to just kind of try and split them up pretty evenly. And let's start turning these other x tiles the other direction. So I'm going to turn this one and a few more of these. We'll just turn a few of them and try that. This is one of those trial and error things. So I'm going to try putting those along here. And then I'm going to try filling in right here. And since I have 12 unit tiles, this should work out well because I have 3 by 4, and 3 times 4 is 12. So let's see if putting those there will fit into a rectangle. Okay, so that worked out well, which means I've found my dimensions. So this x squared tile has length x, and then these x tiles have length or width, whatever you want to say, but this dimension right here is 1. So that's a 1 and a 1 and a 1. And then along this side, again, this x squared tile has length x or width x, either one. And then each one of these x tiles has width 1. And then you can see how they're kind of snapping into place. Love that. So you can see that we've created that rectangle that has those properties. It has the area, 1 x squared tile, 7 x tiles, 3 here, 4 here, and 12 unit tiles. And the dimensions of that rectangle are x plus 3 by x plus 4. So that would be the factored form, x plus 3 times x plus 4. So basically we're doing what we did, what we've been doing in Chapter 7, where we started with these binomials and we multiplied them together to get this polynomial. We're doing the opposite. We're starting with kind of the answer. We're starting with the product, and we're factoring it into what two things would you multiply together to get that product. Okay, so this is the one in your book. So get your book out. And again, they want us to use algebra tiles. This time we have x squared plus 11x plus 18. So I've got 11x tiles, which means I'm going to be adding some more here. So that's 4, so that's 8 because I added one more. 9, and then I'll probably add some on this side too. 10, 11. So let's see. Let me turn those. Okay, let me recount, make sure I have 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and then of course we've got to fill in with those more units, and we're supposed to have a total of 18 units. Right now I have 3, 6, 9, 12, so I'm only supposed to add 6 more. So 1, 2, 3, 4, 5, 6. So I can't add any more units, which means I can't actually finish this rectangle the way that I've done it now. So I'm going to have to play with it. I'm going to have to change some things around. So maybe we move some more of these tiles down here, because again, the area is an x squared tile plus 11x tiles plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 plus 18 unit tiles. Okay, so this still isn't going to work, right, because I have, I wonder if I can make this any bigger. I have a gap right here. So if we took this one and turned it, and I don't think it's really going to let us leave it down there. Oh, that's frustrating. We need this to be bigger. But if you can imagine this being right here, then we can take all of these units and use those to fill in, and then see these last two would go right here and right here. And it's not going to let me do it because it's too big. But use your imagination to pretend that this last X tile is here, and then these two unit tiles are right next to it. So those are going to be my dimensions. We're going to get rid of that one, and we're going to add these here. Oh, and the bin is full, right? But we'd have 1, 2 more, remember? So our dimensions are x plus 2 by x plus 9 is how we got that rectangle. So this would be x plus 2 by x plus 9 would be the two binomials you would multiply together to get this product. And of course you can check that. This is your answer, but you can check that by foiling it back out. So let's FOIL it real quick. X times x is x squared. That's your first. Outer would be x times 9. Inner, 2 times x. And last, 2 times 9. You combine like terms in the middle. That's x squared plus 11x plus 18. So that is, in fact, what we were trying to factor. And that means that our answer is correct, since when we FOILed it, we got what we were trying to factor. So again, this is your answer. This is what we're trying to get to. Now, what's neat about these, if you look back at these, what you may notice looking at these numbers is that the sum of these numbers, 3 plus 4, is that middle number, or the coefficient of your middle term, and the product, 3 times 4, is your last term. So the sum of these numbers, 3 and 4, is the coefficient of your middle term, and the product, 3 times 4, is your last term, your constant. Same thing here. 2 plus 9 is 11. 2 times 9 is 18. And we're going to use that fact to factor on the rest of these examples without using algebra tiles. So all we have to do is find the two numbers that have a sum of 8 and a product of 15. So first let's write down all the numbers that have a product of 15. We could multiply 1 times 15 to get 15, or 3 times 5. Those are the only options. And to get a sum of 8, of course, we could add 1 plus 7, 2 plus 6, 3 plus 5, 4 plus 4. We've got lots of options, but the only one that gives us a sum of 8 and a product of 15 is the 3 plus 5. And actually, I'm going to redo this. I'm going to do this the opposite direction. I think it makes more sense. So we're looking for a product of 15. That means multiply, or that, either way, and a sum of 8. And so again, we said the factors of 15 are 1 and 15, 3 and 5. Then we want to find their sums. 1 plus 15 is 16, 3 plus 5 is 8. So if we're looking for a sum of 8, these numbers gave us a sum of 8. That means our binomials would be x plus 3 times x plus 5. So that's the factored form of x squared plus 8x plus 15. And again, you can check that by FOILing that back out. So again, this is your answer, but you can check it using FOIL. So first, x times x, outer, x times 5, inner, 3 times x, and last 3 times 5. Combine your middle two terms, and we do get x squared plus 8x plus 15. So we found the two binomials that you would multiply together to get this product. Now the one in your book. So again, we're always looking for a product of our last term that has a sum of our middle term. And actually, you know what? I'm going to change that from product to factors, because that's really what we're looking for. We're looking for the factors of 24. Factors being numbers you multiply together to get 24. So the factors of 24 would be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are all the factors of 24. Make sure you're very organized about it. So I always start with 1 times my number, and then I just increase from there. So now we're looking for the pair of numbers from our factors of 24 that also have a sum of 11. So 1 plus 24 is 25, not 11. 2 plus 12 is 14, not 11. 3 plus 8 is 11. So those are our numbers. So our binomials are r plus 3, r, because that's the variable they've chosen to use this time, and r plus 8. That's your answer. That's factored form. But again, you can FOIL to check and make sure your answer works. R times r is r squared. R times 8 is 8r. 3 times r is 3r. And 3 times 8 is 24. So you can see when we combine those middle terms, we do get r squared plus 11r plus 24. So that's the correct factored form. Okay, example 3, we're doing the same thing. The only difference is we have a negative sign here. So we're still trying to find the factors of our last number that have a sum of our middle term, but now the middle term is negative 11. So first of all, the factors of 24. 1 and 24, 2 times 12, 3 times 8, 4 times 6. But if you'll notice, when I add these together, I can't get a negative number. A positive plus a positive is a positive, right? And I can't just make one of my numbers negative, because a negative number times a positive number would be negative 24. So these aren't the factors of positive 24. These would be the factors of negative 24. The negative times a positive is a negative. So the only way to get a positive product is either by multiplying two positive numbers together or by multiplying two negative numbers together. A negative times a negative will still give me my positive product of 24. But that way, when I add a negative number and a negative number, I can get my negative sum. Negative 1 plus negative 24 is negative 25, not negative 11. Negative 2 plus negative 12 is negative 14. Not negative 11. Negative 3 plus negative 8, though, is negative 11. So now when I write my binomials, instead of x plus 3, it's going to be x minus 3 times x minus 8. That's your answer. And again, you can FOIL to check it. So x times x, x squared, x times negative 8, negative 8x. Negative 3 times x, negative 3x, and negative 3 times negative 8, positive 24. Combine those like terms in the middle, x squared minus 11x plus 24. So it does, in fact, give us the correct product. So that's our answer. Now the one in your book. Again, you're looking for the factors of your last number that have a sum of your middle term, or middle coefficient, in this case negative 6 again. So first I would always just write my factors just ignoring positive and negatives, right? So just 1 times 8 or 2 times 4, those are the factors of 8. But then looking, I can see there's no way I'm going to get a negative sum using these numbers. But I also can't just change one of my numbers to being negative, because a negative times a positive won't give me a positive. So since my product is positive, I'm going to have to multiply a negative times a negative number to get a positive number. And I can add those negative numbers to get my negative sum. So negative 1 plus negative 8 is negative 9, not negative 6. But negative 2 plus negative 4 is negative 6, so those are my numbers. My binomials are y minus 2 times y minus 4. And I'll spare you from checking this one since we've been checking them as we go. Let's move on to the next example. Same concept, they're just moving around where the negative sign is. So we're still finding the factors of our last number. This time, though, your last number is a negative number. And we want the sum still of our middle term, and it's positive again. So first I'm just going to ignore this negative. I'm going to write all the factors of 15, which are just 1 and 15, or 3 and 5. But the only way to get a negative product is if just one of my factors is negative. So you can try it on the smaller number. Negative 1 times 15 is negative 15. You add those together, you get 14, not 2. Negative 3 plus 5 is 2. So negative 3 and 5 are my numbers. Now I got lucky. What if instead of putting the negatives on my smaller numbers, I chose to put them on my bigger numbers? Well, then we would have gotten a sum of negative 14 and negative 2, not a sum of positive 2. So we would have had to change our negatives to the smaller numbers. And one way you can tell where to put your negatives, whether it be on the smaller or the bigger number, is by looking at your sum. If your sum is positive, then your negative number has to be the smaller number. Because the only way to get a positive sum is if your bigger number is the positive number. That means the positive number wins because there are more of them, and that's how we get our positive sum. So our binomials here are x minus 3 times x plus 5, because that's a positive 5. That's the factored form. Again, you can check it using FOIL. First, x times x, x squared. Outer, x times 5, 5x. Inner, negative 3 times x, negative 3x. Last, negative 3 times 5, negative 15. Combine your like terms. So x squared, that's plus 2x, because 5x minus 3x is 2x, minus 15, which is what we were trying to factor, so our binomials are correct. Back to your book. Again, we're looking for the factors of our last term, which is negative 36, that have a sum of our middle number, which is a positive 9. Factors means numbers you multiply together. First, just ignore the negative. Write all the factors of 36 starting with 1 times 36. Then 2 times 18, 3 times 12. And of course, if you don't know these, use your calculator. Put 36 divided by 2 in the calculator. It'll show you that it's 2 times 18. 2 times 18 is 36. And then do 36 divided by 3. And it's 3 times 12 that gives you 36. Then do 36 divided by 4. Use your tools. So 36 times 9. Or 4 times 9, sorry. 4 times 9 is 36. And then finally 6 times 6. Now, again, we're supposed to have a negative product. You can't get a negative product from multiplying a positive number times a positive number. So one of these numbers has to be a negative number. Which one? Well, you could just guess and throw your negatives on the small one first. Try that. If that doesn't work, then you can change your negatives to the big number. Or you can look at what you want your sum to be. We want our sum to be positive. If we want to get a positive sum, then we need our smaller number to be the negative number. And you'll notice that every sum we get will be positive because we've made our smaller number the negative number. Negative 1 plus 36 is 35, not 9. Negative 2 plus 18 is 16, not 9, but closer. Negative 3 plus 12 is 9. So those are our numbers, negative 3 and 12. We just finished this table out so you can see that neither one of these works. Negative 4 plus 9 is 5. Negative 6 plus 6 is 0. But all of our sums, with the exception of 0, were positive because we put our negative on the smaller number. So factored form is n is our variable this time, minus 3, times n plus 12, because that's a positive 12. And again, you could FOIL that to check it. Back on notebook paper. Says the area of a rectangle is given by the trinomial x squared minus 2x minus 35. What are the possible dimensions of the rectangle? Use factoring. So really this is just like using the algebra tiles. We have a rectangle and we're trying to figure out what the length and what the width is across the top and down the side. But instead of actually using algebra tiles, we're just going to use the method we learned, which is finding the factors of the last term that have a sum of the middle coefficient. First, let's ignore the negative. 1 times 35. You can't divide 35 by 2. 2 is not a factor of 35. Neither is 3 or 4, but 5 is. Now, I can't get a negative product using positive numbers. I know one of my numbers has to be negative, but not both, because a negative times a negative still wouldn't give me a negative 35. So one of these numbers has to be negative. You can guess and check, so you could try putting the negative on the smaller number. Let's see what happens there. We get a sum of 34 and a sum of 2. Neither one of those gives us the correct sum. So since that didn't work, just try putting your negative on the other number. 1 plus negative 35 is negative 34, not negative 2, and 5 plus negative 7 is negative 2. So those are our numbers, 5 and negative 7, and we could have known that without guessing, just by looking at the fact that we wanted a negative sum. The only way to get a negative sum is if your bigger number is your negative number. So that means the answer to the dimensions of the rectangle would be x plus 5 and x minus 7. Positive 5, negative 7. Those would be the dimensions. 1 would be the length, 1 would be the width. Those would be the dimensions of the rectangle. Okay, in your book, same question, the dimensions of the rectangle. So again, you want to find the factors of your last number, which is a negative 72, that have a sum of your middle coefficient, which in this case, we have that understood 1 there, so it's a negative 1. The factors of 72 are 1 times 72, 2 times 36, 3 times 24, and this slanted line is bothering me, of course. 4 times something, 36, 18. And again, you could be using the calculator for this, so just do 72 divided by 2. So it's 2 times 36, 72 divided by 3. 3 times 24, 72 divided by 4. 4 times 18. If you weren't sure if 72 is divisible by 5, try it. It's not. You've got a decimal. 72 divided by 6. 12. So that's another pair of factors we need to put on there. 6 and 12. 72 divided by 7. If you weren't sure, try it. And it's not. 72 divided by 8 is 9. And then those are only 1 away from each other, so that's when we know we're done, because after that we would have 9 times 8, but we really already have that, 8 times 9. But again, to get a negative product, you can't multiply a positive number times a positive number. One of these numbers has to be negative. You could just guess and try, so try all the smaller numbers negative, then try all the bigger numbers negative, see which one works. Or you can look at your sum. Notice the fact that we want a negative sum, and the only way to get a negative sum is if our bigger number is the negative number. So I'm going to put all my negatives on the bigger number. I'm looking for a sum of negative 1. So 1 plus negative 72, negative 71. And again, if you struggle with this, put them in the calculator. What is 1 plus negative 72? It's negative 71, which is not the sum I'm looking for. I'm looking for a sum of negative 1. So then do 2 plus negative 36. Negative 34, not negative 1. 3 plus negative 24 is negative 21, not negative 1. 4 plus negative 18 is negative 14, not negative 1. 6 plus negative 12 is negative 6, not negative 1. But notice how we've been getting closer. That this sum has been, the non-negative part of it has been getting smaller. 8 plus negative 9 is negative 1. So those are our numbers for our binomials. We're writing the dimensions, so the dimensions are x plus 8 and x minus 9. They're asking for the dimensions, so it's a length and a width instead of writing x plus 8 times x minus 9. This is how we're writing it. Okay? Okay, finally, last example. So this is back on notebook paper. We have x squared plus 6xy minus 55y squared. So the difference here, and it does look kind of crazy, but it's really not that more complicated, is that we've just added in this second variable. Well, that's really not going to change much of what we do to find our answer. We're still going to look for the factors of this last number, which now is negative 55, that have a sum of the middle coefficient, which is a positive 6. So the factors of 55 are 1 and 55, not 2, not 3, not 4, or 5 times 11. But of course I want a negative product, so one of these has to be negative, either my smaller numbers or my bigger numbers, but not both. And then I want a positive sum. So if I want my sum to be positive, then I want my smaller numbers to be my negative numbers. And of course, again, you could guess and check and revise if that's too confusing. So negative 1 plus 55 is 54, not 6. Negative 5 plus 11 is 6. So those are our numbers. So now here's where the difference comes in. Instead of just x minus 5, it's x minus 5, y. Because the y is that coefficient that's in the, or the variable factor, sorry, that's in the back. And then instead of just x plus 11, it's x plus 11, y. So that's the only change when you have that second variable, is it's just going to get attached to that second number. Now let's see what happens when we FOIL. X times x gives us that x squared, which is our first term. X times 11y is a positive 11xy. That's all you're doing. Multiplying 11 times x times y, and it's 11 times x times y. We just write it without the times sign. Then negative 5y times x is going to be negative 5x times y, or y times x is x times y. And then negative 5y times 11y, a negative times a positive is a negative. 5 times 11 is 55. Y times y is y squared. Combine these like terms in the middle. They are xy terms. Their variable factors are the same, so they are like terms. 11xy's minus 5xy's is 6xy's minus 55y squared. So notice when we FOIL it back out, we do get the original product that we started with that we were trying to factor. So don't let that extra variable intimidate you. All you're going to do is attach it to that back number. Do the one in your book, and we're done. Okay, so again, we're looking for the factors of the last number, which in this case is negative again, that have a sum of your middle number, which is 6. So the factors of 27, we're going to ignore the negative while we write the factors, just 1 times 27, not 2 or 3 times 9, and that's it. It's not divisible by 4 or by 5 or 6 or 7 or anything else. So that's it. Those are our factors. But of course we need a product that is negative. This is our product, negative 27. So we need either our small numbers to be our negative numbers, or we need our big numbers to be our negatives, because remember we're multiplying those back together to get the product, negative 27. Since we want a positive sum, we want the smaller numbers to be negative so that when we add them together we have more positive numbers and we get a positive sum. So negative 1 plus 27 is 26, negative 3 plus 9 is 6. That's our sum. So we have m minus 3 in. Just attach that in to your number. And then we have m plus 9 in. So just attach that second variable to your last term in each binomial. And that is it for 7-5 factoring. So basically all you're going to be looking for are the factors of your last number that have a sum of your middle number, and that's how you're going to write your binomials, and you can always check by FOILing. Good luck.